Okay, so we got through. Okay, there was a few that I left for y'all to try on your own. So we're going to pick up with 35. Okay, so we're writing in simplest form, possibly using exponents, but all of our answers we're going to put in radical form. Okay, so this first one we're going to look at is asking us to multiply. However, to multiply radicals, we have to have matching indexes. A square root has an index of 2, index of 3. So we're not going to be able to use multiply, using radicals. So we're going to convert to exponential form. Form says that the index becomes the denominator of the fraction. So this is really 2x to the 1/2, x to the 1/3. Okay, and we want these all to be in one radical. Since the index of the radical is the denominator of the fraction. So one thing that I can do to make these match is I can turn the 2 and the 3 both into a 6. Over 2. I want to make this over 6 as one radical. Make a 2 become a 6, we're going to multiply top and bottom by 3. So this becomes 3/6. To make the 3 become a 6, we're going to multiply top and bottom by 2, 6. And what's really cool is that we can now write this as the 6th root together. So I have it, and the 3 can go to it. So I have a 2 to the 3rd. I have an x to the 3rd. Again, the 6 became the index. And I have an x to the 2nd. Again, 6 became the. And take this, and I can finish it out. 2 to the 3rd is 2 times 2 times 2, which is 8. Then x to the 3rd times x to the 2nd, we can replace with x to the 5th. So we wrote it as one single radical. So we're going to do that same kind of a thing with this one. And the first thing I'm going to do is notice that the index doesn't match, so I'm going to have to use radicals. Okay, I have 3 to the 1/3. I have an x to the, and I have a y to the 1/3. I have 3 to the 1/4, x to the 3/4 times y to the 2/4. And this time the denominator, which represents the index, is a and a 4. So if we want to make these both match, we can turn them both into. So I'm going to write this as 3 to the something over 12, x to the something over 12, something over 12, and again 3 to the something over 12, x to the something over 12, to the something over 12. And to finish this, we're going to look and say, okay, to make this, hold on, this has been. Now we can keep going. And the way that the 3s all became 12s is to multiply by 4. So the 1 becomes a 4, becomes an 8, and this last one also becomes a 4. Side, the 4 became a 12 by multiplying by 3. So the 1 became a 3. It became a, and 2 became a 6. Okay, so now that we have matching denominators, try to combine using before we write it as radical, we can, or we can go ahead and put it under the radical. So I'll go ahead and say, okay, so this is the 12th root. I have a 3 to the 4th and a 3 to the 3rd, x to the 8th, and an x to the 9th. I have a y to the 4th and a y to the 6th. Okay, so we can now combine. 3 to the 3rd, which gives me 3 to the 7th. Then x to the 9th is x to the, and y to the 4th times y to the 6th is y to the 10th. So this is we are looking for groups of 12. And we can look for groups of 12. So there are no groups of 12 in 3 to the 7th. There are no groups of 12 in y to the 10th. However, x to the 17th is x to the 12th with 5 more. One group of 12. And then the x to the 5th is stuck inside. So I have 3 to the 7th, x to the 5th, y to the 10th. I don't remember because I cut off the directions, but if the directions make us use absolute values, since the index started even and x has an odd power, put these absolute value bars around. Okay, and that's the type of process that I'm looking for. Okay, next view. We'll look at some addition, subtraction, multiplication properties. So 37, in order to add two radicals, we have to have matching. Okay, right now root 20 and root 5 do not match. So we're going to take 20. 20 is 2 times 10 times 5. Since the square root, the index is 2, we're looking for groups of 2. 2's that can come out. And these 5 is stuck on the inside. So we have 2 square root of 5. Now we can add these. 2 square root of 5 minus 3 square root of 5 is just negative 1 square root of 5. So it's just negative. Okay, the next one, the index does match. So unlike the last few on 30, the index match, we can go ahead and divide these. Square root of 12 divided by the square root of 2 is the same as the square root of 12 divided by 2. 12 divided by 2 is just the square root of 6. You take 6 and break it down and you look for groups of 2. We have 2 times 3, no sets of 2 of the same number. So square root of 6 is my final answer. Okay, next one we have a 3 over square root of 7 minus 2. What to do here is rationalize this denominator. So I'm going to go ahead and put if it was one piece, we would multiply the radical by itself. But since there are two pieces down here, we're going to multiply by the conjugate. So root 7 minus 2, we're going to multiply by root 7 plus 2. And you can FOIL first, outer, inner, last this whole piece out, but we said multiplying radical conjugates is the same as first squared, last squared. So square root of 7 squared, square root of 7 times square root of 7 is square root of 2, or sorry, 2 times 2 gives us, okay, but what we do to the bottom, we have to come do to the top. So I'm going to multiply again by root 7 plus 2. And either I would have to FOIL, or if there's just one piece, distribute the 3. This becomes 3 square root of 7 plus 6. So I have 3 square root of 7, 6, divided by 7 minus 4 gives me 3. And then if I can reduce these fractions, I will. So I have 3 root 7 over 3 plus 6 over 3. 3's cancel and leave me with root 7. Oops, this is a 3. And 6 divided by 3 gives me a plus 2. Okay, so I have square root of 7 plus 2. For 39. All right, last one here on the page. Right now, we cannot add these because they don't match. So before we start this problem, we're going to see if we can break this down. So I've got a 3 square root of 20x. I'm going to start there. I'm looking for groups of 2. Is 4 times 5. 4 is 2 times 2. I can take out my group of 2. 5 in the x. Okay, there was also a 3 on the outside to start with. So that becomes 6 square root of. And then I'm going to do that with the next piece. So I have an square root of 45x. Okay, so I'm going to take 45. Okay, 45 is 9 is 3 times 3. So I can take out my group of 3. And the square root of 5 and the x are stuck inside. Again, we had this 8 to add in front. So I multiply by 8. And that gives me 24 square root of 5x. Okay, last piece, same thing. I have a minus 4 root 5x. 5 is just 1 times 5. There are no groups of 2, so it just is going to stay minus 4 square root of 5x. Simplify first. Now you notice that all of these radicals match. And when all the radicals match, and then we're just going to deal with the stuff in front. So right in front we have a 6 plus 24 minus 4. Plus 24 is 30. And 30 minus 4 is 20. So my final answer is 26 times the square root . Okay, next two we are multiplying. For this first one, if you notice, we do have two radical conjugates. So you can use your trick, which is first squared minus last squared. Or you can go through and you can FOIL, but you'll notice that the inner outer terms should always end up canceling. Okay, so I'm going to show FOIL in case you forget the trick. So for starters, I'm going to take 3 times 3, which is 9. 3 times negative root 2 is negative 3 root 2. Positive 3 times root 2 is positive 3 root 2. And negative root 2 times 2 is negative 2. Now if you notice on the inside, again, we have negative root 3, and both of those are going to cancel. So all I have to do to finish this is take 9. And 9 minus 2 gives me 7. Next one, same thing. We've got root 2 plus 7, or root 7 squared. So you could write this as root 2, 7, 2 plus root 7. And you could FOIL. However, I also taught you a shortcut, and the shortcut says to multiply something squared, squared. So root 2 times root 2 is just 2. 7 squared, which is 7. term, you're going to take 2 times the 2, so times root 2, 7, which is a positive 2 square root of 14. And last thing we can do here is combine the 2 and the 7, so my final answer is 9 plus 2 times the square root of 14. Okay, the last few on the review ask us to solve, which I think we've done all these in class, but just in case you need a refresher, isolate the radical. But if you notice on this first one, it's already isolated, right? If you draw an imaginary box around the radical, there's nothing else there to undo the radical. So I have square root of y minus 2 is equal to 4. Square root, we are going to square both sides. Squaring a square root essentially gets rid of it. And 4 squared gives us. So the final step here, we're going to add 2, and we get y is equal to. It's always good to go through and check and make sure it works. So if I plug in 18, we're expecting to get minus 2 is square root of 16. 16 is 4. Since 4 equals 4, that kind of confirms things correctly. Okay, so that was 43. 44. This time we are going to have to isolate. So again, I'm going to pretend a box around the radical. And if it's not inside the box, it's got to move before we get started. The first thing that I'm going to have to do here is add, so this is negative 2 times the square root of y plus 1 equal to now 6. Divide by negative 2. I get the square root of y plus 1 is equal to negative 3. Okay, now that it is isolated, we can work on finishing this. However, we've talked a little bit about how square roots are never going to equal negative 3. That's kind of a red flag. So I'm going to go ahead and say, okay, if I know the square root equal to a negative after I've isolated, I think it's possibly going to be no solution. But in case you forget, let's go ahead and finish. So to undo this radical, I'm going to square both sides. Get y plus 1 is now equal to 9. I subtract 1, I get y is equal to 18. But before we circle, I've got negative 6 minus 2. That's the square root of 8 plus 1, and we want to know if that is going to give us 0. 8 plus 1 is 9, so I have negative 6 minus 2 square root of 9, which is negative 6 minus 2 times 3, which is negative 6 minus 6. And negative 6 minus 6 is negative 12, equal to 0. Okay, if we get an answer, 8, and it doesn't work, when we plug it back in and check it, that means that there is no solution. Okay, last few, which is kind of hard to see, so I might have to rewrite it. I'll start with 45. 45 is the cube root of x plus 10. First step is to isolate, so I'm going to subtract 10 from both sides. And I get the cube root of x is equal to negative 2. Now this time we have a negative, but it's an odd index. An odd index can be negative, so we can keep going. We square root, we square both sides. So to undo a cube root, we are going to cube both sides. Root of it, and negative 2 to the third power is just negative 8. Okay, if we check these, I'll just kind of do it mentally this time. cube root of -8 is just -2, and -2 plus 10 does give us 8. Okay, next one, I'm going to do 47 and then I'll do 46 last. Okay, we have the square root of 3x plus 7 equal to x minus 1. Okay, first step, undo the radical because it's already isolated, so I'm going to square both sides, which leaves me with 3x plus 7. And if I do it to one side, I have to come do it to the other. We have two options. Either you can use our trick, or you can come and say x minus 1 times x minus 1, and you can FOIL. But you cannot just say that this is, okay, because there's a middle piece. So we can take x times x, and that gives us x squared, and -1 times -1 gives us 1. Middle term, we have to take 2 times x times -1, which is -2x. If we have an x squared left, we're going to have to solve this by factoring. By factoring, we have to get equal to 0. I'm going to take this 3x and I'm going to subtract 3x from both sides. Positive 7, and I'm going to subtract 7. 0 equals, so I have an x squared minus 5x minus 6. Okay, so I'm looking for factors of -6 that subtract to give us -5. This -6 tells me my factors have to be different. So I've got a 1 times 6 and a 2 times 3. When we subtract 2 and 3, we get 1. 1 minus 6, we get 5. +1 and a -6. So I get +1 and a 0. Okay, we said my answers are always opposites of my factors. So if +1 minus 6 are my, and -1, 6 are my solutions. Before we circle both and move on, we're going to have to check our answers. Now we're going to come and we're going to check to see if they work. So we'll start with -1. We have 3 times -1 plus 7, and we want to know if that equals -1 minus 1. So that is 2, 3 plus 7. Does that equal -2? We have the square root of 4, -2. Positive 2 does not equal -2, so we are not going to circle. So then we have to check the 6. Again, we have 3 times 6 plus 7, square root. And we're trying to give, sorry, my pen froze. Okay, is that the same as 6 minus 1? 15 plus 7, so that's square root of 25, which is 5. 6 minus 1 is 5. And since it works, the only answer that I'm going to circle or give is x equal to 6. This one's kind of an ugly one because it has decimals. Okay, so we'll talk about process first thing. It's already isolated. X minus 3 to the 4/3 equal to 8. Okay, first thing I'm going to do is undo the radical. And we said when it's kind of an ugly one or an exponent, we're going to raise it to the reciprocal power. So 4/3 and 3/4 It's essentially going to get rid of itself and leave you with x minus 3. But if I raise one side to the 3/4 power, I have to raise the other side to the 3/4 power. I'll give you a whole number, but when you put it in your calculator, this is going to give you a really long, ugly decimal, so we're going to use 4 point. I'm going to round to the nearest hundredth. However, when we raise to the reciprocal power, you've got to look. Maybe it would be helpful if you could see that. Okay, you're going to look at the fraction. If either one of those pieces is even, which 4 is even, value bars around when you solve. Okay, all that does, we have x minus 3 equal to 4.76. We also have to come solve x minus 3 equal to negative 4.76. I'm going to add 3 to both sides, so my first possible answer is 7.76. I'm going to come add 3 to both sides, and my second answer should be 76 is negative 1.76. Go through, it's probably good that we go ahead and check them. So when they're positive numbers, we can just go ahead 7.76 minus 3 to the 4/3 power. Okay, do you get 8? And if you take 4.76 power calculator, you get 8.00, so it works. Okay, on the other side, 1.76 to the 4/3 power. Sometimes, well, that will be negative 4.76 power. That in your calculator will give you an error message. If it gives you an error message, then take 3, and you're going to do this in 2 steps. So you're going to take the cube root of negative 4.76 to the 4th. If you take the 4th root of first, you end up getting 513.36, and the cube root of that is 8.00. Circle. So sometimes when you have negative numbers, you are going to have to use it. If it still gave you an error message, then you would not use this second answer. Okay, but I'll try to give you some that don't have it. And that should be good. The rest of the answers of the problems that I did not finish are posted on Edmodo, so you can use those. I think that's it. All right, good luck.